You're listening to the Stephan podcast, focused on Bitcoin and Austrian economics. Listen in and learn alongside me as I interview some of the sharpest minds ranging from economists, software developers, investors, entrepreneurs, and writers. Hey guys, my guest today is Laolu Osuntokun, also known as Roasbeef. He is the CTO of Lightning Labs and a highly talented developer, leading a star team working on the Lightning Network. I recently had the chance to meet Laolu and Connor Fromnecht, also of Lightning Labs, while they were in Australia for the recent Lightning Summit, and showed them around Sydney for a day, which was a great learning experience for me. Both really cool, talented, and hardworking guys. Just a quick note before the interview, please note this one is more technical and not suitable for a Lightning newbie. If you're new, I recommend first listening to certain earlier episodes of my podcast, particularly episode 23 with Rusty Russell for a great intro overview on Lightning, and also episode 9 with Brian Vu. Once you've listened to these interviews, I think you'll be in a better position to listen to this one with Laolu. Also, apologies and just a caution that there was some scratching noise. I've done my best to minimize that and cut it out in post-production, but there was only so much I could do. Also, this interview is quite fast-paced, so I recommend listening with headphones and not speakers for this one. Hi Laolu, thanks very much for coming on the show.
Yeah, it's good to be here.
Yeah, so it's been a while since the Lightning Summit was on, and now you are back home. How's things back home?
Not bad. Just, the usual, back to work. Just the regular stuff. But Australia was great also. Like, I'd never been there, and I was like, wow, this is actually, it's like spring here. This is different.
Fantastic. Yeah. So look, Laolu, I know you told me on the day, but I just thought it would be, I thought it was an entertaining story. Yeah. So if you could just maybe tell the listeners, what is the origin story of the Roasbeef name?
Okay, yeah. I feel like I've, told this a few times. I guess it's never really been written down. But, so Roasbeef came about, I think when I was in 9th or 10th grade. So maybe this is when I was 15 or 16 or so. I was basically I was playing World of Warcraft at the time. And at that point, Blizzard actually kicked everyone off the private servers I was on. So okay, maybe I'll actually go on to the public servers. And I needed kind of a character name. I remember I just got back from football practice. And my mom got me some Subway. So I was kind of sitting there in computer trying to make my name for my Orcurrenta or on the game itself. And I was putting a bunch of different names. I couldn't get anything going. And I was like, okay, well, I'm eating a roast beef sandwich right now. I had a Subway Club. I put in roast beef with the T that was taken. I was like, damn, what am I going to do now? And I took off the T and then it wasn't taken. And then from there on, the past 10 years, I'm always roast beef and everything. I'm roast beef on everything other than Instagram. There's this Norwegian kid that has it. I've messaged him a few times. I guess he's not going to give it up. But if you see a roast beef on the internet, it's probably me.
I know. Doesn't he know who you are? Come on.
I don't know. The best part about roast beef, I think, it's just kind of funny. It's kind of we're doing all this serious cryptocurrency, Bitcoin work. It's oh, roast beef. It's I don't know. I think it makes me laugh, which is why I like it.
I love it. Yeah. So, look, you just came back from, sort of roughly a month ago, November in 2018, we had the Australian Lightning Summit in Adelaide. So can you maybe just give an overview on, what it is and what happened?
So basically Lightning Summit, this time in Adelaide. So some people may not know, but originally we had a summit in Scaling Bitcoin. This was in 2016, Scaling Bitcoin Milan. We kind of we're at the office of BHB. And at that point, we were all kind of be working on kind of Lightning implementations ourselves. We decided that, okay, this is a good point to actually, kind of synchronize and to make sure they're interoperable. So that was a 2-day thing or so. And we decided, okay, we're going to do it again. The point of this one was kind of not really the super far off, next gen Lightning stuff, but kind of the things that we all know that maybe really need to get in, things kind of dual funder, splicing, AMP and things like that as well. So it's kind of a 2-day thing. We talked, so mostly it was kind of deciding what people were interested in getting in. We kind of going to leave the kind of specifications on the mailing list. And right now there's lots of traffic on mailing list right now about kind of the nitty-gritty details of things that are actually going to go in next time. But I thought it was great. Adelaide was a great town. I've never been to Australia. We had some time to check out some other cities as well. But I thought it was a pretty productive trip. And we actually got a lot more done than I thought. Because initially we had this really, really long agenda. I was like, damn, are we going to get through everything realistically in 2 days? But at the end, we even had time left over. We just got some beer and okay, well, great job everybody. So that was great. Fascinating.
And then what was the most exciting in terms of the technology coming out of the Lightning Summit?
So some of the cool stuff, so I think we actually kind of had this cool kind of rendezvous protocol that I didn't realize was actually possible before. That's gonna be pretty cool because that can add some increased privacy into the system itself. Another cool thing is kind of there were some measures added for light clients. So things where you can, rather than maybe you watching the chain, you can kind of get an SVB proof that the channel was closed. and a bunch of like other like quality of service stuff. Probably the biggest thing that I thought was important was kind of like fixing some issues with the way that we handle fees in the protocol. Whereas before, basically, we had to kind of like guess ahead of time what the fees were going to be, and that's something actually we didn't really anticipate would be like a huge issue. Once we actually went to mainnet, it was a big issue because implementers were actually kind of like disagreeing on what fees we actually need to have. When you disagree on fees, then well, you have like a lot of issues. So instead, we're going to move to a protocol where instead of like agreeing on fees ahead of time, you can basically add on fees after the fact, right? And this is going to be via kind of like a child pays for parent type thing, where you can basically have like an anchor output and you can kind of like bring down the transaction after the fact. So I think that's probably like one of the biggest quality of service things I think we're gonna get out here. And I'm pretty excited about that because fees in general can be pretty hairy, and this kind of like sidestep it all into the last moment, which I think is going to be a big difference.
Yeah. So in terms of that child pays for parent concept, what will it help smooth the experience on? Will it basically be helping you close a channel?
Yeah. So basically, it's helping you close your channel. So right now, like, because we have to agree on fees ahead of time, you basically need to guess ahead of time, like, kind of like what the fee will be when you want to go into the chain. And in the future, the fee rates could spike, right? So the worst case is basically, I have a fee rate, and like, let's say I have like 10 satoshis a byte, and all of a sudden the fee spiked to like maybe 70 satoshis a byte. All of a sudden, I can't get in, and I can't actually re-sign them. I can't re-sign my transaction if the other party is offline as well, right? So maybe, if they were online, I could basically issue like a new kind of like update fee in the protocol. We could raise the fee. But if they're offline, all of a sudden I'm stuck with this low fee transaction. The other thing is that like, because the outputs are like CSV towards me, I can't actually broadcast that and anchor it down myself, right? Because the CSV only starts taking once it actually hits the chain. So as a result, you can kind of be in a weird situation where it's like it's very, very difficult to guess fees ahead of time. But in the protocol now, there's a bunch of good actually hooks in the protocol to allow you to actually when you overshoot fees or undershoot it, you can kind of correct that. So now we don't really won't really worry about fees as much, because now at this point we can just know, okay, well, after I broadcast it, I can regulate my fee as much as I want to.
Fantastic. And then could you maybe give a bit of a background on AMP and what changed in terms of AMP from the summit?
Oh, cool. Yeah. So AMP is kind of like this thing. It's called like atomic multiplier payments, and it's basically like a method to allow you to kind of like shard payments in the network. So right now, like on Lightning, like let's say you have like 5 channels, you can only actually fully send or receive with one of those channels, right? Which is pretty limiting. So let's say I had like 5 $10 channels. All of a sudden, I can't actually just send $50, right? I can only just send that $10 at once. What AMP lets you do is it basically lets you kind of like combine the liquidity of all those channels and like actually push or receive them all at once. This is actually a big benefit for the network as a whole, because all of a sudden now we can now more effectively kind of like utilize liquidity within the channels. And also it's pretty good for kind of like erratic nodes, because now like larger channels are less important. They're less important because now like with larger channel, the channel I would only be able to send a payment if I could like actually route entirely through that channel. But now I can basically share my payments amongst a bunch of other like smaller channels, right? So we had the original version of AMP, which was kind of like based on this like secret sharing mechanism, which would allow the receiver only to pull the payment only once all of the pieces got there. Then some people started to work on a different version of the mailing list, which is kind of like called like base AMP or like MPP or something like that, which is a little bit simpler, and it kind of like reuses the same payment hash. The idea there is that like you can actually still maintain kind of this invoicing protocol that we have going on here, which you can with base AMP as well too. But I think this is probably going to be one of the biggest things as far as kind of like quality of service routing the network, because all of a sudden now like I can like utilize the full bandwidth of the network at any given moment rather than like being restricted to a single path. And this is also pretty good for privacy as well, because now like all the payments are now like more sharded, and like you can't as easily triply correlate like a larger payment, because now I will see like 10 or so payments come by, and they may all be from different payments, or they could all be to the same payment itself.
Right, and obviously my understanding on this is not as deep as yours, but with the concept of splicing, which I understand as resizing the channels that you already have. Yep. It's sort of like AMP is like an alternative to that, because you don't need to resize the channels, you just use multiple ones.
Not necessarily. I mean, so you can say that like, AMP is good because it reduces the pressure on the network to have like really, really large channels, right? So before, like, let's say I want to send $1,000 payment, I would need like a much larger channel to send on that. But now I could maybe send my $1,000 payment over a series of $100 channels, which is pretty good. So splicing and AMP, they're complementary. So like, AMP lets you do, so splicing lets you do some cool things, where I think one of the biggest things it'll let people do is like, on the UIs right now, maybe most of the UIs have like 2 balances. Maybe they have kind of like an off-chain and on-chain component. And that's because like, your coins are in 2 different areas. With splicing, you can kind of like, really combine them to like one single balance, because all of a sudden now I can send a payment outside of my channel. So I don't really have to close my channel to send out a payment. It's also a case where it's like I maybe even want to like have most of my hot water coins in a channel, because now like they're kind of like more liquid. I can move them a lot more easily. Another cool thing that splicing allows, I can effectively give you an address, and you can kind of like deposit into my channel as well. So it's a thing about kind of like contracting the size of the channels, but AMP is more about kind of like routing throughout the network itself. But I think, splicing is pretty important for kind of like wallets in general because it really improves the UX of wallets. Because all of a sudden now I can like, instantaneously move in and out of my channels at will. And all of a sudden now it becomes like, like the line between layer 1 and layer 2 kind of blurs a little bit more, where it's kind of like, well, this is my wallet. My wallet can move, small amounts quickly, or maybe a little bit larger amounts, a little bit slower, depending on kind of like the fee thing. So I think at that point, like once we have that in, it kind of be a thing where, users can trade off kind of like fees for time, as in, maybe you pay higher fees and it's going to be a little bit slower, or you pay more fees and it's going to be a little bit faster. Those are kind of like ratios that you can modify depending on what you actually want to do with your payments.
Right, I see. So again, my understanding is not as great as yours, so if you could help me on this.
Yep.
The AMP component does not require to do an AMP payment is all on Lightning, right?
Yeah.
But to do a splicing, that requires an on-chain payment. Is that what you're trying to get at there as well?
Yeah, that's true, right? So like a splicing attempt would basically, so what it does more or less, it basically like closes a channel and opens a new channel in a single transaction, right? So I basically broadcast a transaction that spends the old multisig and then creates a new multisig, and that new multisig is the 202 for the brand new channel. But the cool thing is that, doing that transaction, we can basically add and remove funds from the channel itself, right? So let's say I wanted to pay my friends and also maybe deposit to an exchange. I could do that all in a single transaction. So what happens now is that, like, every single Lightning implementation over time will kind of have like a pretty cool like batching engine implementation, something we're working on right now in L&D as well, where you can basically kind of like feed in all of these transactions that you do otherwise and coalesce them into a single transaction anytime you're going to splice in and out or any other transaction on chain. So it's going to make things a little bit more efficient as well, because now we have this kind of like, spot that we can all kind of synchronize on, and we can send payments or receive payments, via a single transaction on chain. It's a pretty cool feature, because now it's like, batching will be kind of like a native thing in most implementations. And also in the future, whenever we get kind of like, signature aggregation, then things will be a lot cheaper and a lot smaller from there on out.
Excellent. So could you maybe just outline a little bit for me around using batching within LND?
Yeah. So basically, so something that we've been working on for a bit. One of our engineers, Yos, has kind of like had this idea when he joined. Was like, well, let's make this kind of like new form of sweeping, right? So one thing that Lightning implementations need to do is that they need to ensure that they're able to kind of like sweep outputs from CSV or kind of like CLTV transactions, right? So it's like a very, very basic thing to do. Initially, we had something called the UTXO nursery, which is kind of like a thing where it would like incubate outputs until they were mature, because it was a CSV or whatever else. But then we realized we can kind of like generalize that a little bit more to kind of like what we call like a sweep within LND. And the cool thing about this is that like this is kind of a system where like every single block is going to basically ask anything in the code base, like if it actually wants to sweep a transaction or not. And this is cool because all of a sudden now like we can use this as a primary synchronization point. So like let's say we're doing a splicing transaction, and I had like channel A and I wanted to add more funds to it, but then let's say at the same time we had a request to make a channel B, right? Rather than like doing a transaction for splicing and then from opening the new channel, we can combine those into a single transaction, right? And then even further, let's say that I wanted to send a payment out at the same time, I can basically combine that into a single transaction itself too. So like the sweeper in LND will basically become kind of like this really cool batching engine, where ideally like LND has one transaction a block, and that one transaction is doing things like opening channels, closing channels, sweeping HDLC, sweeping the CSV, sending payments, and doing everything in that single transaction. And this is pretty good for us because we're going to save on fees, obviously, because we have less transactions on chain. And also like, the system as a whole is more efficient because every single transaction is more batched, and you can save more money, when you actually batch transactions as a whole.
Excellent. And you mentioned a UTXO nursery. Could you outline a little bit around what is that concept?
Oh yeah, so it's something I made like a bit back, and so like whenever you close a channel, whenever you force code a channel on Lightning, you have like a time lock output, right? As the person actually force codes the transaction, and this time lock output has like a CSV value, and CSV meaning that like there will be like a delay until you can sweep it, right? So back in the day, I guess this is like 2015, 2016, I was like, well, let's make a UTXO nursery. The idea is that like anytime you close a channel, you give the output to the nursery, and the nursery kind of like watches over the output until it's mature. And by mature, I mean that can actually be swept, right? We can do the same thing as well for CLTV transactions, as in like before we can broadcast it, we give it to the nursery, and the nursery like handles kind of like figuring out like when the actual maturity height is itself. It was a pretty cool abstraction that like worked at that point, but we're kind of like working to kind of generalize a little bit more. But like I think the naming kind of made sense. It's kind of like, well, I have like a kid output, maybe it's in the crib, and eventually graduates to kindergarten, and kindergarten is when you get swept into the wallet at that point.
Yeah, I suppose that's also from a privacy point of view, that's an improvement as well.
Yeah. So I think we can do some really cool things as well with that, because like in the future, whenever we move to kind of like having channels either be, 2 of 2 ECDSA or 2 of 2 Schnorr, that's really cool, because at that point, like every single channel, if assuming, you're doing cooperative closes where you're just like signing the multisig, looks like any other regular payment, right? So right now, like, channels in Lightning are pretty identifiable because you have like a 2 of 2 multisig, and we're really the only people that are using 2 of 2 multisig in, witness script hash with all the new SegWit stuff, right? But in the future, that's going to look kind of like a regular witness key hash, using ECDSA, or even kind of like a new witness program type using Schnorr. The cool part about this is that now, like anytime you open and close a channel, it looks like a regular payment, right? So let's say I'm doing like a splicing operation, and maybe I have like 4 inputs, and maybe I add some outputs, and I also have my new multisig. That looks like maybe more kind of like a send mini or a coin join, right? So now we're basically increasing an anonymity set of like Lightning users and also regular users for Bitcoin payments as well. So it's a world where maybe it may be the case that kind of like smart contract and regular payments are kind of like indistinguishable, which is really good for privacy, because all of a sudden now like the anonymity set is basically everyone using either Bitcoin or Lightning. And in the future, if it's going to become more popular, it's a lot harder to kind of like tell things apart.
Yeah, fantastic. Okay. And then probing. Can you tell us a little bit about this concept of, okay, so you've got different channels across the whole network, and you as one node don't necessarily know what's going in some other area of the network. Yep. How does probing help?
So probing can help in terms of kind of like, I'd say it probably helps the most of kind of like weeding out like, poor nodes or poor channels, right? So this is something that kind of like Alex Bosworth has been working on for us a little bit. Basically, like we're having the system where we're kind of like probing the network slowly to figure out like where the bottlenecks are and also like which nodes are actually viable, right? So if you can know ahead of time that like, Bob, always drops payments or he's never really online, you can avoid them altogether, right? And also you may be kind of like able to wiggle out different nodes to force them to close their channels if the channels themselves aren't really being managed effectively, right? So you can say that like if we can give people some of this data, they can have like, better pathfinding attempts, because all of a sudden they know which paths are viable, which ones are not viable. And this is just kind of like a good way to kind of like be doing like a ping throughout the system. So you can say that eventually, like, so there's something called Tor, and they kind of have like a directory authority. And what they do is they more or less kind of like go around different nodes, like, measure down things like that latency. Also maybe, kind of like stop people trying to do DOS, things like that. This is kind of similar to that, as in like we may be kind of, or I mean, other people in the network, I'm seeing it like on my traffic miner right now. They can kind of be probing people slowly to see if the channel is actually good or not. So I would say it's kind of like, it's basically improving the network by removing, poor candidates effectively. And if you can ignore this candidate when you're doing your pathfinding, your route will be a lot more successful, and you'll be able to like do things a lot more easily.
Right. So it overall improves the strength or the quality of your experience when you interact with Lightning Network.
Exactly.
And so my understanding, I think from listening potentially to, I think this was noted with Rusty and Christian,
yep.
and they were mentioning around this concept that came up that you want to try to preserve privacy where you can in the Lightning Network, and then only where there starts to be many routing failures, that's when you start to introduce more and more sort of slightly weakening the privacy, such that you can improve the experience. Can you chat a little bit on that?
Yeah, I guess maybe I'm not sure exactly what they're talking about there, but I mean, it's a thing where, like via probing, you can basically, more or less kind of like weed out bad nodes, right? It's this thing where it's like, I think they were talking about a thing where you can kind of like identify like your probing attempt as kind of like a probing attempt. Therefore, people may not really worry about a time lock in that. The other cool thing about like probing is that like, it kind of like adds cover traffic for the network as a whole, right? So if like every single node kind of like randomly like sends a payment to some other node that they know is going to fail, that's kind of like extra cover traffic for like regular payments, right? Because even with onion routing, you still have a bunch of kind of like, vectors as far as like timing and packet analysis. But if there's kind of like a steady state of like volume on the network, it's a little bit harder to kind of like tell that someone sent a payment or not. So you can imagine, like, let's say there were no payments going on the network at all, like only one person sent a payment. That may be more identifiable to kind of like someone that's monitoring a bunch of links versus kind of like there's kind of like a bunch of noise going on, everyone's sending payments back and forth, and you slip your own payment underneath there. So this is something that mixnets do, which is another way to kind of like have privacy preserving communication on the internet, where they basically have a bunch of like covered traffic going back and forth. And they do things like where they have like random delays, and like they may even like add dummy traffic. So I think these are things that Lightning nodes themselves start to do, where I may just start to kind of like randomly route payments towards myself in kind of like a circular fashion to like just to ensure that like they can't really tell when I'm receiving a payment myself, and they don't really know who the destination of the origin is. So it's kind of like a supplemental thing on top of like the things that we have already as far as like onion routing and kind of like picking your peers to be distributed.
Right. Okay. And now another big topic that I wanted you to touch on was Wumbology. So
yeah.
Can you give us a background? What is Wumbology?
Well, Wumbology is the study of Wumbo, and Wumbo is the opposite of Minnie. And it's basically from this episode on SpongeBob where it's like he has like Mermaid Man's like belt, and like he's like trying to use it, and Patrick's like, hey, like you're doing it wrong. We have a set to Minnie. You want to set to W for Wumbo. And he's like, what's Wumbo? Like, well, Wumbo is like, I Wumbo, you Wumbo, the study of Wumbology. It basically just means big, right? It's the opposite of Mini. And it's kind of like a joke that we developed in terms of like making channel size a little bit larger. So some people may not know is like right now on the network, we kind of have like two limits as far as payments. The first one is a limit on the channel size, which is 0.16 BTC. The other one is a limit on the like largest payment, which is 0.04 BTC. These were kind of said initially back in the day is more or less kind of like trading wheels, because obviously like things are still like very, very new. We're also kind of figuring things out ourselves. We also didn't really want people to kind of like throw a bunch of money onto the network before things were really robust. But I think maybe we're kind of like getting a little more comfortable with our implementations, and in the future, we may have this kind of like special feature bit, right? So on the network, whenever two nodes connect, they can exchange information, kind of like telling each other like what new extensions they support. So let's say like, I connected to you in ISO, you had the Wumbo bit set, which means you like have big channels, and I had the Wumbo bit set as well. Then at that point, we may be able to make a 1 BTC channel, which is like, far larger than the actual current limit on this network right now. And so it's a thing where it's like, because it's double opt-in, like only once two implementations really agree that they're ready to support it, will actually roll out. And because like we have these feature bit system, it's pretty easy to introduce new features in the future, because all of a sudden we just say, okay, well, bit 25 means this, and then at that point we can go on from there.
Fascinating. And so the growth of the network has been quite a lot over the last few months. Have you guys done much in terms of benchmarking on how the network operates?
Yeah, I mean, so I guess we're doing two things. One of the things we're doing right now is like you were saying, we're kind of like, poking different nodes around the network to kind of like see really like, like how readily are they able to accept payments, also forward them, successfully themselves. It's something that's pretty cool, because now like we can kind of like develop, more or less like a framework to kind of like analyze different nodes in the network in order to like maybe suggest channels to different users at that point. And that's kind of like more like a quality of service thing. It may be the case that even though you have like a lot of BTC on the network, you may not be effectively like actually managing your routing node, right? If you're not effectively managing your routing node in terms of like liquidity and also like balancing your channels, you may not actually be a good candidate, right? So like that's one of the things that I think people have trouble with at times. Like just because a node has more channels and like maybe has like more BTC onto the network doesn't necessarily mean they're going to be a good candidate for routing nodes, right? So like that's kind of like a thing of information asymmetry and kind of like the skill of routing an operator, also like how aware they are of routing nodes themselves. Like I said, on the other point, as far as like performance, I mean, so back in the day, I did a bunch of kind of like estimates on like LND or actual benchmarks, and this is when the protocol was a little bit different. Like it basically had more of a window for like having for like kind of like pipelining throughput. I think at that point, like I got like 2 or 3K transactions per second on my laptop in LND. I think these days, because we had a lot more persistence and there's a lot more kind of redundant checks, maybe it's around like 8 or 9 100. Or around 900 transactions per second on a single channel. But I mean, that's one of the things where it's like on a single channel, and like the way LND is designed, it can kind of like really scale across all cores, pretty easily. It's one of the things where it's like right now our main bottleneck as far as like forwarding throughput is just kind of like disk IO, which means like writing to disk a lot, and that's not really optimized at this point. So I think those are pretty good numbers, just because like things are just not optimized at all. I think it'll be the case that like only once we actually see us like reaching those numbers on like a regular basis, we actually go down and like try to optimize that stuff out right now, because beyond that there's kind of like a lot of safety things that we're working on right now as far as like safety and quality of service, reliability of LND itself. At that point, once all that's done, like people's nodes are falling over because like there's some new streaming video Candy Crush game or something like that, then we'll actually go in there and kind of like tweak things up a little more, optimize it.
Right. And so with that 900 transactions per second, was that just using an LND in a test environment with another LND? Or?
Yeah. So it was just 2 LNDs at that point, and with pretty kind of like negligible latency, but actually doing like real disk IO. And then if you put it on the network, it gets similar to the thing to that. But I guess there's 2 things to point out. Is like right now there are kind of like 2 kind of like caps on the protocol. One of which is kind of like a cap on the number of outstanding HTLCs, which is the number of kind of like pending HTLCs that you can have that aren't yet settled, right? So you can understand, like, if this number was like 10, well, okay, that's going to really, really reduce our throughput. But right now it's around like 900 above, 900 cumulatively, which makes it a little bit better. But that number can be bumped in the future. Another thing that that was in the past, before we kind of like did some of the specification stuff, is that like in the past, like you'd be able to have kind of like multiple unrevoked commitment transactions, which would let you kind of like pipeline these updates a lot more quickly, similar to the way that TCP sliding window works. That was kind of like removed, for simplicity, but that may come back, at some point in the future.
Right, and then. What about benchmarking from a routing success or failure? What percentage of payments successfally route? Have you guys? I assume you guys have done some benchmarking on that also.
Yeah, I mean, so do you mean like nodes that are actually on the network, like this people are operating, or?
Because sometimes one of the angles people say is, oh, look, I tried to send this payment, but I just get all these routing failures.
Gotcha. Yeah. I mean, so like, I feel like that's more of an issue, again, talking about like, the kind of like skill of a routing operator, where like we're saying, like, it's not really at the state yet where you kind of like just like dump money on there and like set and forget, right? You have to be actively managing your channels. So one thing we're kind of like, looking at the network right now, we're trying to like identify actually, like good nodes, as in they're actually like able to like route payments like pretty effectively. And something that Alex Bosworth has been working on in the past like few weeks or so. He probably has better results than I do right now, but yeah, he'd probably be a better person, to inquire the way things are going on right now. But yeah, I mean, so like typically most of those issues are just kind of like nodes not being down or people just not really like, balancing their channels effectively. But in the future, we'll have like, a lot more tools coming out to make these things a lot easier to use. And also, I think like, there's a thing right now where it's like there are a lot of routing node operators that they're really, really excited about stuff, but then maybe they don't really understand kind of the implications or really like what to do or kind of like what all like the little settings do and things like that. I think with time, as we get more tools out there and also kind of like more guides, resources, all that will improve, pretty a good bit.
Yeah. And then is the idea that autopilot will also help do some of that channel management as well in terms of rebalancing, splicing, that kind of thing?
Yeah, definitely. So, I mean, so kind of like the autopilot system that we have right now is one that I wrote, like, a bit back. It's like, it's pretty basic. All basically kind of like what it does is try to like tend the network to kind of like a scale-free network, which means that there's going to be kind of like a low degree, with the network, which means that like, there'll be kind of like like the actual path length for like the shortest path, which should be pretty low. Something we're doing right now within the company, Lightning Labs, we're really working kind of like moving that to kind of like the next generation of the system is something that kind of, like one of our engineers, Johan, and then also, Alex, and Yoast have been working on it themselves. And the idea is that like, so right now the system basically has like a single heuristic. We're working on modifying that to like how it to be multi-heuristic. So rather than like looking like, one feature, one attribute, it'd be kind of like go on a series of other attributes themselves. And there'll also be ability to kind of like add your own external coordinate into the system itself, which will let you kind of like add supplementary information that may not be, completely identifiable from the graph itself. But in the future, like autopilot would definitely grow to be doing things like, actively managing channels. Because maybe the case, let's say I have like channel A. And channel A itself, isn't really getting that much volume, and like I really have a lot of money in there. But channel B is doing a lot. But channel B maybe isn't able to capture as much volume because maybe it doesn't really have enough liquidity in the channel. So what the system can do, it can identify that and say, okay, well, I will take money away from channel B and put it towards take money away from channel A and put it towards channel B, maybe in the hope that like I can actually get a lot more money out of channel B versus channel A. So it'd be more or less kind of like a resource management engine for both your channels and also your payments itself. The cool thing is that you can actually like you can actually change data between these two systems as far as like making channels and also sending payments, because there may be some overlap in there as like maybe someone that's good as far as like always like write up payments pretty effectively, maybe they also get kind of open a channel directly too.
And also related to channel management, and you were mentioning there around transferring fee, the balance across channels.
Yep.
Another concept there is the which I'm sure you've spoken about, is around the dual funding aspect of it. So is the idea that once dual funding comes in, that would be the new default for channel opening?
I don't think so necessarily. I feel like dual funding is one of the things that people think is going to like solve all the issues. And like actually like the initial version of LND, the first thing I coded was dual funding channels, right? So LND today supports dual funding channels. We even have tests for it and everything right now that works, but it's not really yet exposed on the on the network or on the RPC. Because the thing about dual funding channels like require a little bit more kind of like upfront negotiation. Because it's the case like even if like I think you're a good person or whatever else, I may not really accept, I may not want to actually put money up in dual funding channel. Because at that point, like if you go down, like, my coins are actually locked there too. Well, the difference is like for a single friend channel, I can basically just instantly open a channel to anyone else, and there's really not really much thought that they're going to put in because they're going to accept the channel. While for a dual friend channel, because like you both have money up, it's a little bit more of kind of like a more of like an involved relationship, right? You may not want to accept dual friend channel from just anybody, but you may be accepting single friend channel from a single person. The other thing as well is that I think there really aren't as good as tools there for people to kind of like do rebalancing the channels and managing liquidity. But like the past few months, we've exposed some tools in LND or kind of like some RPCs, and we've seen people start to actually like write a bunch of open source tools, start do some of these things. We'll have some coming out ourselves. So I think dual funding channels are important, but like I think they'll probably be used more heavily amongst kind of like other businesses or exchanges rather than kind of like on the network in the wild, just because like they do require a little more of kind of like a thoughtful relationship between the two parties compared to a single friend channel.
I see. Okay. And so one of the arguments I've seen by this computer science professor, I'm not sure if I'll pronounce his name correctly, George Stolfi. He basically, he made an argument that routing won't be feasible. So he was trying to say, look, finding a viable payment path in the LN requires knowing the channel states, which are unknown by definition. There is not enough data to solve the path finding problem, no matter how many developers you put to work on it. Now, Greg Maxwell did weigh in with his thoughts on this, which is, as I understand it, it's essentially the point that Lightning is not dependent on absolutely perfect routing. Therefore, you don't need to know all that global information, and you don't need it to be completely current. So do you have similar thoughts, or would you articulate a different answer to that challenge?
Yeah, I think you're totally right. Because like unlike Bitcoin, like every single Reddit node does not need to have like the actual same view of the network as a whole, right? So if you ever seen any of these explorers, you kind of like see that some of them have different numbers than others. That's because like you don't need a global view of the network. You don't also need like synchronized view amongst every single node in order to actually do these, in order to actually do writing successfully. So I think it's a thing where he's like looking after this kind of like really idealized model, but like it's one of the things where like in practice, like that stuff doesn't really matter, right? Like there are a number of kind of like impossibility theorems and kind of like CS or things that are kind of like deemed like very, very hard problems. But it's typically the case that in practice, if you add things like a little bit of randomness, then it's fine, right? You may not be able to find like the theoretically optimal solution, but you have like an okay solution which works in practice and is okay. It's one of those things where I think it's also funny where it's like whenever you're working on a problem, someone tells you it's impossible, you're like, well, I guess I'll work a little bit harder on this, right? So so I think it's a case where you don't need global information because like at that point you can make adjustments, right? And because you can kind of like iterate and kind of like make adjustments and kind of like feel a little bit more out of the network, you can more effectively route. So you think of it like right now we have something in L&D that we call mission control. And it basically learns from like your past attempts, like which routes are more likely to be effective in the future. So once again, it's kind of like a pretty basic version that we have right now. But some of our engineers, Johan and Yost, they're working on a more kind of advanced system, which will kind of like factor in the probabilities that like certain routes work well based on the past experience. So it's one of the things where you don't need global information, and also like if you remember basically which routes worked before, you can kind of like you bias yourself to going to Bob again because you did things more successful in the past. Then you can have like a lot more, you have like much higher success rate when actually doing routing.
Right. And you mentioned there's also the potential of retrying. So you could try the payment, it might fail, but then you can retry and we'll find another route.
Exactly. And so it's one of the things like, just like on the internet, right? Like whenever I'm sending a packet somewhere, like it may have failed like, three or four different times versus, either due to like timeouts or queues were full or something like that, or like, maybe like routes change, but to the end user, that was really never surfaced, right? So I think it's the same thing in Lightning, right? Even though like you did payment, maybe you had like 5 attempts and like the last one worked, like that's okay, right? As long as that like the latency, isn't super perceivable for the end user. And like, whenever you're doing anything, like the idea is always like the lower level is going to like kind of hide like much of the details and give you kind of like a much more abstracted presentation as far as like what's going on.
Right. Okay. And so I think that pretty much answers that question. How about now Neutrino? So that's BIP 157 and BIP 158. Yeah. But I suppose before we get into this, can you maybe just give an overview on what Neutrino is and what problem it's solving for the non-technical people?
Oh, definitely. Yeah. So Neutrino is basically a new kind of like light client or SPV mode for Bitcoin. So, typically the version that people are using right now on their phones, it came out maybe like around like 2013 or so. That's like BIP 37, right? So the way BIP 37 worked, it basically did something, put all your addresses in something called like a Bloom filter, which is this kind of like probabilistic data structure, meaning that like sometimes it's going to tell you something is in there, but it may not actually be in there, right? So what the BIP 37 nodes do, they basically send this Bloom filter off to the full node, and then the full node for every single block can kind of like check against the Bloom filter to see if an address is maybe yours and then send you the entire block. This has some issues because like all of a sudden now you're more or less giving all your addresses to the full node, and they can do things like kind of like get several of these Bloom filters and intersect them to kind of like more effectively figure out what your addresses are. The other thing that was an issue with BIP 37 is that like actually caused a lot of strain on full nodes, right? So there are a bunch of kind of like nuisance DOS attacks that you could do. You could basically have like a Bloom filter that matches everything and cause the full node to always center every single block, right? And so at that point, like the full node also had like a bunch of state for each client, meaning that every single client that connects to it had to have more and more shit that went on further and further. And just generally, like BIP 37 has been proven that like it's very, very difficult to kind of like manage the filters themselves, right? So the idea was that the clients would themselves kind of like manage their false positive rate of the filters and tune them, more or less depending on what actually going on. But I think in practice, none of the implementation actively did that effectively, and they had some issues with that. So what Neutrino is based on this this old post. I guess it came out in like 2016 by this kind of like a poster on the Bitcoin mailing list called the BFD. The idea there, which I think was also developed in kind of like an IRC of Bitcoin Wizards a few times in the past, the idea was kind of like to flip it, right? Rather than you giving the full node a filter, the full node gives you a filter, right? And the filter basically contains information about like what addresses or outputs may be in that block. So that's what Neutrino is, right? So what it is that every single block we can download a filter, we can check that filter locally to see if there are any of our addresses in that filter, and then we download the block itself. The cool thing about this is that I can like download the block and filter from two distinct different nodes, right? Or I can even download the block from, maybe using a little more kind of fancy cryptography in a way that allows me to, indistinguishably fetch the block itself. And this is really cool because all of a sudden you can use this for a lot of other things. For example, like your rescans in in different full nodes, typically they actually like have to like read the entire block and scan everything for the addresses. Instead, they can actually just read these filters and check them themselves, which makes things a lot more faster. I think it's just like a much better way to kind of like build applications on top of Bitcoin, because all of a sudden now I have this filter, and this filter, typically most applications, as far as like contracts with Bitcoin, like you need to know if something happened in a block, right? And with the filter, you can effectively find out if something happened in a block or not, because you download the filter, you can check it there, and it's fine. And like, yeah, so that's kind of like an overview of Neutrino.
Yeah, right. And then my understanding is that Neutrino is now in LND and Lightning App Alpha for testnet.
Yep.
Has the use of it been successful in testnet?
Yeah. So I think people were like, we like a testnet because all of a sudden, like, you don't really need a full node, because like otherwise you need to like, maybe wait several hours, 6-7+ hours. You have like a really good computer to download the entire blockchain. And obviously then, you have like a lot of space implications there too. Oh, one thing I forgot to mention, that one of the reasons that we actually went in the path of Neutrino is that BIP37 has like a bug, you can say, where the full node can actually like lie by omission, meaning that an event happened, but it won't really tell you about that event, right? So typically maybe, if you're doing like regular wallet, that's not so bad, because that's kind of like, well, you have some money there, but you don't really know about it. Maybe you find out later. But in the case of Lightning, when you need to kind of like act on events in a blockchain in a timely manner, if the full node like kind of like censors you or kind of like blindsides you as far as notification, that may cause you to kind of like miss an event, as far as like a breach or something else that happened there. But yeah, I mean, so right now it's on testnet. People using on testnet, using like LND. It's built into LND. Also, like, we also use BTCD to kind of like actually implement the PDP protocol on it itself. And I think the main thing is that you can sync pretty quickly and get up to speed in the network, in a timely manner. And I think this is what people are going to be using primarily as far as like end users on kind of like their phones and their laptops, right? So it's a case where right now it's mostly kind of advanced users, because they need to like be able to kind of sort of full node and also kind of like monitor the full node. But once we get Neutrino out there on mainnet and beyond, then it's going to be as easy as kind of like downloading an application on your desktop or on your mobile phone. And then at that point, I think like the fun really begins, because at that point, like people can ship applications more easily, because all of a sudden now they have like a wider user base. And also there's kind of like less maintenance on their end as far as like full nodes or whatever.
Yep. And then do you foresee Neutrino style wallets becoming the norm for mobile wallets, or are there any other negative trade-offs associated with it?
I think they may, because like in my opinion, like I think it's much simpler than actually coding up BIP37, right? Because like I mentioned with BIP37, you have to do kind of like active management of your filter on the client side in order to ensure kind of like you're managing your false positive rate effectively. And also on the full node, there's a lot of work you need to do as far as like tracking filters for every single client, updating the filters and things like that. So I think on a whole code wise, it's much simpler. Like you were saying, there are some drawbacks. Of course, everything has drawbacks. One of the drawbacks is that like you'll have like higher bandwidth users than normal, because typically with BIP37 you're only actually downloading kind of like a Merkle root of the transaction from the full node, which can be pretty compact, right? But for Neutrino, you're actually going to get the entire block. So it's not as bad, because like, with SegWit, there's something where you can actually get a block without the witness data, meaning you can get a block without all the signatures, which can be kind of like, a large portion of the block. This makes the blocks a lot lighter. Maybe you can download maybe like, 60 or 70% of the block versus the entire block itself. One of the kind of like drawbacks of Neutrino is that like we don't actually get unconfirmed transactions, right? Because we're always, getting filters from actual blocks, we don't know that a transaction is in the mempool that you can actually validate. It's one of those things where it's like, as a live client, you weren't even really able to validate that an unconfirmed transaction was actually valid, right? Because you didn't really have the UTXO set. So I think it's more of a thing where it's kind of like more of like a user experience thing, where people are typically used to whenever they get someone sent, a payment on their phone, they see, okay, boom, there it is. Like I have it going on there. So one of the things where we can add this onto Neutrino as well, just by kind of like either fetching every single transaction, or this idea that I guess haven't really talked about millions yet. You can kind of get like a stream of just kind of like the address and the amount from a full node of every single thing in their mempool. And at this point, you'd be able to effectively filter this out, and at least have like a UI indicator that, okay, boom, here is the here's the payment that you've been receiving.
I see. So if I understand you correctly, it's Neutrino style mobile wallets will definitely show you all your confirmed transactions that have been sent to you.
Yep.
But as they currently exist, if it's an unconfirmed transaction that has been broadcasted but not necessarily confirmed into a block, that will not show in your Neutrino style wallet.
That's true.
However, as I understand it, you're saying there are ways to try and mitigate that also.
Yeah. So there's ways we can do it on top of it to get that. But I think for our use case, we don't really care about things in the mempool, because the mempool, doesn't exist, and you only care about blocks. And so it's also like kind of very difficult for you to kind of like try to like spend things in the mempool, because it could be double spent. There could be other things like that. But once you're in a block and you have some confirmations, it's a lot easier, right? But in the future, I think,
I see.
Yeah. So I feel like, to me, in my opinion, kind of like unconfirmed transactions in a wallet are really just more of like a UX thing, right? People want to kind of like have like the thing, okay, well, like an instant experience where you maybe onboard someone to Bitcoin. They say, okay, wow, like, it arrived like right there on my phone. we can emulate that, via other mechanisms, but then obviously we also have Lightning for these kind of like instant payments in the future.
Right. And then are there any other reasons are there any reasons that Neutrino technology would be difficult to implement into all the other mobile wallets, or do you think it's just going to come over time?
I think it may come over time. It's one of those things where it's like, we'll see kind of like how BIP37 and, 157, 158, emerge. So, some people are like on the network right now, even disable BIP37 altogether, because it was seen in the past that maybe some agencies were using this to kind of like, try to probe your node for their mempool, or even kind of like for de-anonymization attempts. So some places basically have like a flag to even turn BIP37 altogether. So I think that maybe people will switch over if they're, comfortable with the trade-offs of Neutrino itself. But like I was saying, I think from a code perspective, it's a good bit simpler because there's less kind of like active management. There's another thing where like right now we're kind of like in the first stage of deployment of Neutrino, where you basically get like the filter and you kind of like get more or less like a committed history from every single one of your peers about the kind of like validity of that filter. But in the future, that may actually be committed into a Bitcoin block, similar to the way we have like a commitment for all the SegWit witness data. So it could be the case that like rather than like using this kind of like thing on the side to kind of like distinguish invalid filters from not, you get it in the block, which gives you a high level of security.
Right. Yeah, there's a lot, and it's obviously this is quite difficult for me to follow along on that. Yeah, but definitely very interesting stuff.
Thank you.
Yeah. So what would you say is at the top of your wish list for changes that you would like merged into Bitcoin Core?
Ooh, I've got a lot. So I mean, I probably like one of the things that like probably like lowest hanging fruit, which I think does a lot for kind of like off-chain protocols in general, is sig hash no input, which is a way to kind of like allow signatures to be a little more liberal. So basically, the way right now signatures work, typically people use something called sig hash all, which basically says I'm signing all of the inputs and all of the outputs and their output of value and everything else. The idea of that is like if someone took your transaction and modified it in any way, the signature would be invalid. So this is like a pretty big thing, because otherwise someone could take your transaction, modify the output value, or even stick in their address, and all of a sudden you're sending money to them, right? That's why sig hash all is kind of like the most conservative one people use generally. But there are other sig hash flags that maybe can be used for other things, right? For example, probably one of the use case people know about the sig hash flags is like maybe back in like 2014, 2015, when Mike Hurd made this thing called Lighthouse, which is a way you can kind of like do like a crowdsource, crowdfunding type thing on Bitcoin itself, and that use sig hash single and anyone can pay, would basically let people kind of like collaboratively make like a much more larger transaction. So no input is basically like, taking everything back and saying, I really only want to just sign, I want to give you a signature, and it's valid as long as the witness is satisfied, which means I can pull money out. This is cool because all of a sudden now, like typically the way when you're making contracts on Bitcoin, you're kind of like doing more or less kind of like nested transactions, and those nested transactions, depend on another transaction before them. If that other transaction is kind of like broken or modified in any way, then you can't really pull them in effectively. But now sig hash no input basically opens things up for you to do a lot of really cool things. Probably the most thing I'm really excited for with no input are basically better ways to be doing fees. Things like L2 needs them. Also, like there are a number of things you can do with like kind of like multi-party channels, which I talked about in scaling Bitcoin, that are only really possible once you have no input. So I think it's one of those things where it's like a very, very small change to the system, but in my opinion, the things you can do really, really blow up once you actually have that change, in there, which I'm really looking forward to. Other things I'm looking forward to are something called kind of like texting on stack, which is the ability for you to check like an arbitrary signature in the script itself, and Bitcoin script itself, which is pretty cool. Because all of a sudden, let's say I can make like an address, a special address that like maybe I can send it with my key. But if you give me like a key from yours, and I can like sign that key, I can basically delegate that amount to you. You can do a number of cool things, kind of like Laolu protocols, like micropayments, probabilistic payments, oracles, delegation, things like that with with texting on stack. But I mean, beyond that, there are a number of other things, but I feel like these are the things that kind of like are really, I think people generally agree that they're good ideas, and they're also like pretty small changes to the system itself.
Okay, so what service or product would you like to see built on top of Lightning Network or using LND?
Oh, cool. Yeah, there are a lot, actually. I mean, so I think one of the most impressive things over the past year or so has been like all the developers building on LND. So like they've been building like a lot of really cool things, different hackathons. There's like the chain code residency. There's also kind of like all the Lightning hack days going along right now. Probably like one of the things that I thought about like a while back, which someone has built now, which I'm really excited about, is basically kind of like a Chrome extension that uses LND to obtain macaroons to send, to allow like different websites to more or less kind of like have like a very seamless user experience, right? So rather than like you clicking like upload and read, like you go to your wallet, clicking OK, you you basically just click the upvote and the payment happens in the background, right? So I think that's a really cool thing as far as like UX within the system, because it really lowers kind of like the cognitive burden of doing micropayments. Because rather than like, you approving every single payment that's happening, which, can be pretty taxing, you can maybe set like a budget or something like that, or give like a particular node some other, kind of capabilities. Another thing that I'm pretty excited for self-building eventually, which I gave a talk on, maybe in like 2016 or so, something I called like HTLC Dash, which was basically a way to, so basically, whenever you're shooting a video on kind of like YouTube or like some other thing, they basically have this kind of like adaptive streaming protocol, which means that like, anytime your quality dips low, that's maybe because like your bandwidth was getting choked up, or maybe it can scale up to 1080p. So the idea is basically to like, kind of like layer Lightning payments on top of that, where maybe I would pay you less for a 480p versus a 1080p video. We'd also do it in a way where every single chunk that you give me is actually an HTLC within the system itself, right? So I'm paying for the next 30 seconds at a time. I'm paying for those 30 seconds within Lightning itself, which is a pretty cool thing, because now like it's kind of like solve like a fair exchange problem. So at that point, you can have like effectively like streaming videos or podcasts or movies or whatever else, pay for over Lightning by the minute or by the second or whatever, which I think is a pretty cool thing there. So I think once people kind of like get in the realm of doing kind of like really cool streaming activities, maybe I'm like, getting my paycheck streamed to me, by the minute, or maybe I'm kind of like, streaming some of the video. I think it's a pretty cool use case that I'm excited for. And that also really combines with, other kind of like UX enhancing things like, Joule, the Chrome extension, and other things like that. I guess another thing that I think is pretty cool is kind of like gaming in the context of Lightning. So you can kind of like, either accept payments for your game, or you can sell kind of like a cool premium sticker for your game, or you can even like, in-game payments. So I can maybe like, have like a, some gold or whatever that I buy for Lightning, or maybe when I like, beat the boss, they give me some payments or something like that within itself. So I think that's a pretty cool use case, and I'm looking forward to as well.
Yeah, so it looks like there's, potentially a lot of different business models that can be enabled with Lightning. And as you mentioned, streaming on demand, gaming, all sorts of new services that could really, well, we'll see, but it may help reinvent the internet as we know it and reduce some of the reliance on advertising and clickbait.
Yeah, and also just kind of like removing a lot of these intermediaries, like, like Stripe or whoever else, where it's like, I think one of the things that people kind of like underestimate is that, like when you have Lightning, it's easier than ever for you to like just put something up on the internet and accept or send payments, right? Before this, it was more difficult because you basically have to go to some other third-party provider. You have to kind of like give them your credit card information and do all the KYC and everything else, which is pretty limiting, or PayPal, whatever else. And at any given time, they can also shut down your account, right? With Lightning, it's like, well, I just have like my program, I put it up on the internet. I have my node. I say, hey, let me get some connections. All of a sudden, I can like, I can accept payments on the internet with very little cost. The marginal cost is also very, very low because we have these great open source tools that are being put out by different developers. And all of a sudden now, like, this has never been possible. This hasn't been possible before because now the barriers to entries are much, much lower. So I think like there were many things people maybe wanted to do, but they couldn't do in the past because of the legacy system. But now the Lightning is there. It's a lot more open. It's transparent. There's respect. There's open source implementations. I think now we're really starting to see people kind of like, putting these things together and really having these cool models that, couldn't exist before, but are able to exist now due to Lightning.
Yeah, fantastic stuff.
Yeah.
One other topic that we touched on this briefly on that day when you came to Sydney.
Yeah.
But we were touching on this concept of how Lightning's spec might be a little more, let's say, well-defined, such that you can have multiple implementations, on Lightning. Yeah. But if you compare to Bitcoin, it's sort of like people are much more, let's say, reliant on Bitcoin Core as being the kind of standard bearer. Mm-hmm. What are your thoughts there in terms of sort of the comparison there in terms of how Lightning Network works versus Bitcoin's kind of consensus?
Gotcha. Yeah, I mean, so like, Lightning itself is like an overlay network. So basically it depends on layer one on Bitcoin. Well, I have opinions about layers and things like that, but, it depends on Bitcoin to kind of like be like kind of like the robust, core to like actually, adjudicate any sort of like disagreement onto like the base network itself. I feel like probably like kind of like the main point is that like on Bitcoin, if you have a consensus fork, you may actually kind of like lose money, right? Someone may double spend you, whatever else, and the risk is like much, much higher. But in Lightning, if two, nodes disagree on like what the current commitment state is, well, that's fine. They can just go to the blockchain and kind of like close the channel, right? I feel like the risk of disagreement on the protocol level for Bitcoin versus Lightning, it's just like it's really on a different level. Because in Bitcoin, it's a lot more dire because all of a sudden you can have all these double spend attacks and like exchange, whatever else. We're seeing all this stuff kind of play out with all these altcoins doing kind of like squabbling amongst each other. I feel like Lightning is it's a lot more flexible because there are a bunch of different types of updates within Lightning itself. I'd say maybe there's probably like 3 or 4 different types of updates. One of the updates is like an end-to-end update. So for example, like AMP is an end-to-end update, right? For AMP, only the sender and receiver need to actually upgrade for us to actually use the protocol, right? Which is pretty cool. So all of a sudden now this is pretty flexible because all of a sudden, developers can be very, very creative. because all of a sudden they don't really need every single node on the network to understand this new protocol. Then there's kind of like a link level update, right? So let's say like we had a new channel and like there's someone made a new channel type, like the 5th channel iteration or whatever else, right? They can start to use that channel on the network today as long as they have the same end-to-end HTLC that actually works in the network right now, right? And then that brings us to kind of like the final upgrade type, in my opinion, which is kind of like a network level upgrade, right? So let's say we were to move to a different hash function within Lightning. Right now we're using SHA-2, I guess a combo of SHA-2 and RIPE-MD. If we were to a different hash function, all of a sudden we'd actually need to kind of like fragment the network, because now you can't route under any single path, right? And this is something that we may do in the future, because we'll be moving to kind of like a Schnorr or ECSA based HTLC versus the regular kind of like hash based HTLC. I think it's a lot more flexible because you have these different upgrade sides. The main thing is that you don't really need global consensus on every single change, right? Or global consensus on like what the current state is. That's the big thing that makes all sorts of implementations pretty difficult in Bitcoin. And also why people pretty squeamish when people talk about some reg new implementation, because they're kind of cognizant of that risk at that level.
Fantastic insights. Okay, how about things at Lightning Labs? Do you have any updates on what's going on with Lightning Labs, what to expect coming up?
Oh yeah, no, there's like a ton of cool things. Like, I guess we don't really talk about it much because we're kind of like really heads down. We kind of like try to ignore all the noise out there as whatever's going on, blah, blah, blah. We just really try to like, continue to execute on what we're going on. But I feel like, the highlights that's coming up is obviously Neutrino on mainnet. That's coming pretty soon. And that's going to be in a few different flavors. One of the flavors are going to be like, on our desktop application, which right now is on testnet, which is being worked on by two of our engineers, Val and Tancred. And then we'll also have actually mobile coming out pretty soon as well, which would be on both, initially on iOS and then also on Android at that point. And I think we're doing a lot of work on kind of like the backend in terms of the kind of like, improving the backbone of the network. These are things like what kind of like Alex Bosworth was working on as far as like different types of doing probing in order to ensure we have like reliable nodes to connect our users to. We're doing a lot of things in terms of like, revamping autopilot, which is pretty basic right now, to have like, taking a lot more different heuristics and like be a lot more intelligent. There's a number of other things we're doing as well. Like, for example, like Connor recently got kind of like an end-to-end test on watchtowers, like the other night, I think last night, which is something people have been pretty excited about, because all of a sudden now you can have a little more assurance as far as taking them onto the network. We'll have that rolling out pretty soon here too. And then on top of that, we have a number of kind of like cool things we haven't really talked about yet coming out as far as like additional kind of like added things on either L&D or the application side of things as well. But yeah, I think there's a lot of really cool things coming out right now. Some of them will be unveiled in like the next month or few weeks, which we're pretty excited about.
Fantastic. And in terms of hiring, are you guys still looking for new developers or any other talent?
Yeah, I guess we're always hiring right now. I think we've been kind of like really like heads down, kind of like to ensure we can ship these things like early next year or so. But at that point, like maybe like earlier next year, we'll be hiring across kind of like front end. We'll always need protocol developers, people that actually be working on kind of like the core protocol that know Bitcoin and and Lightning pretty well. Also be looking for kind of like in the future more kind of like SRE or like DevOps types once we actually start to build out some of these kind of like systems that we're working on there. But yeah, I mean we're definitely continually hiring. You can check out our website, lightning.engineering. And then the careers page and team page will have different listings on there too. But I feel like one of the main things one of the most advantageous things about like actually like running like an open source project as a company is that many of our hires actually like maybe like 4 of them were actually sourced from either contributions on L&D or our application, right? It's pretty cool because at that point, like someone putting up like a really, really good PR demonstrates a lot of things as far as like their ability to communicate effectively, receive feedback, can they use Git well, what's the code style like, testing and things like that. So as a result, I think we can kind of like, save a lot of time on recruiting and kind of like on interviewing because we have like L&D in our other open source projects, right? The thing is like, someone can't fake a good PR. It's like proof of work, right? It's like POW. Like you put up a good PR, it's like all of a sudden you're like, wow, like they're actually serious about this, they're really committed. So I think that's like a really cool thing that like many of our hires actually, were former contributors to L&D. So yeah, contributing to L&D is definitely, great to get noticed. And we've had a lot of cool people coming up. I think L&D is just really continuing to grow and more. I think right now we have like 3.3K stars on GitHub, which is like a good bit. Like I think it's like probably added like 2K stars this year alone. So I think it's like a really cool project. It's probably maybe one of the fastest growing like open source projects like in the Bitcoin space right now, I think, because we have like tons of contributors. Every single release we have new contributors, which is like pretty great.
Okay, and just Lightning Network more broadly, what's the outlook for Lightning Network over say the next year?
Yeah, so I think over the next year or so, we'll be rolling out a lot of these changes in terms of the 1.1 version of the specification, which includes anticipated features like dual funding, splicing, AMP, a bunch of like, really cool things in protocol level as far as like, better error support and things like that. So I think over the next year, like the main thing will be kind of like improving kind of like the backbone of the network. Like I was talking about, like ensuring that we have like pretty reliable nodes. We'll be like, getting a lot more kind of education out there. The thing is the state right now where there may be like a few router node operators that really know what they're doing, while others are kind of like really just picking up nodes, just like sitting it there. So we're getting a lot more guides out there to actually ensure people actually know what's going on, what different knobs are going on there. I think as time goes on as well, like, the education will spread amongst router node operators. People will have like a better idea of like what it takes to be like a router node operator themselves, to actually be doing things effectively. I think in the next year we'll also see a bunch of people, a bunch of work on kind of like the UX front of things. So like I was saying, once splicing is out, the UX becomes a lot easier. So like I said, now we can show a single balance on the wallet rather than like maybe 2 or 3 balances at that point. And I think, as we go on, the network will become more and more reliable because people are able to more effectively manage their capital. And I think we'll also see a number of like cool different things coming out as far as like, people using the network in cool ways. The other day I saw this pretty cool demo. It was kind of like a chess thing where it's like PvP chess. We can kind of like bet on a game and like have that be dispersed out there. But yeah, those things I'm pretty excited about. I think all that kind of like, becomes a lot more, easy once we have like really good client implementations out there on like the light clients on the desktop. And then also once the infrastructure of the routing side gets a lot more, is a lot better.
I'm so excited. There's really so many cool things going on with this stuff.
There's so much stuff. It's like, like I have to keep up with this stuff and then also like company stuff and then even like, Bitcoin stuff. But yeah, there's definitely a lot of news going on. Every day on Twitter, I see new things and like, people in IRC on Slack. Everyone's like just like really, really excited. It's like one of the things that Lightning from Bitcoin is kind of people kind of like, maybe got like more reinvigorated by kind of like application level development on Bitcoin itself. Whereas before it was, pretty difficult to kind of like do development on Bitcoin on your own because it was very, very low level. There weren't really many good documentation. Maybe there weren't really, libraries in your language. But with LND, because we have this system which basically like lets you, script LND in effectively any language, all of a sudden it's a lot easier for you to kind of like to jump in and actually make contribution. And I think the developer network is like growing a lot. I would say maybe like Lightning itself has contributed to kind of like the growth of the Bitcoin developer base, this year and versus anything else. We've seen a lot of, people popping up to do things like training, like on chain code. People are kind of like doing different hack day stuff and like just really getting out there. People are really just kind of like self-organizing, which is great. We put out implementation, there's some docs, maybe there's IRC, whatever else. But we're really passionate about, moving stuff forward. And that's like, really energizes me myself.
Yeah, it's just all so exciting. So look, I think we're pretty much getting to the end of the time. So if you got any last closing comments or just want to tell people where to find you and where to follow you, that'd be great.
Yeah, I mean, so you guys know I'm Roasbeef on Twitter, GitHub, just about everything else. You can find me on LND on our IRC channel. We also have like a developer Slack, which is like really, really like high quality. There's probably maybe like 3,000-4,000 developers. People were kind of like, there's no trolling, there's no BS. People just come out there and they want to like really just like write code and kind of like experiment with the applications themselves. And I say keep on the lookout for the drop of the desktop application, some of the kind of like different services that we'll be coming out with on Lightning in like the next few months or so, which I think people will be really excited about.
Fantastic. Well, look, Laolu, it's been a pleasure to chat with you. I've had to really struggle to try and keep up with you because it's quite a technical and difficult conversation, but at the same time so fascinating. And it's very clear to me that you guys, when I met you and Connor, that you guys are really, you're really working hard and you're really kicking goals. So great work with that. And thanks again for coming on the podcast.
Yeah, great. Thanks so much. Yeah.
Check out the show notes for this episode on my website, stephanlivera.com. If you enjoyed it, remember to subscribe so you don't miss out on the next episode, and please share the podcast with your friends. You can also follow me on Twitter. My handle is @StephanLivera. Thanks for listening.